Hey, this is Erik with Technically Speaking at Source Allies. All right, today we're going to be talking about NICs. This is one of my favorite topics that I've been dying to talk about on the channel, and I finally get to. All right, so we're going to try to keep things high level here because NICs can be somewhat confusing, especially if you're new to the space. It's got what I would consider like different modes of usage, which I think contributes to some of the complexity that people encounter with it. So right here, let's just jump into it. I've got nixos.org right here, and I've deviated. I said I was going to talk about NICs, and yet I have NixOS pulled up. So that is one of the modes of using NICs. NICs has been used to build an entire operating system, based around the Linux kernel, and that is like one of the ways that you can use it. You don't need to install an operating system to use NICs, though. If we go over here to nix.dev, NICs is also a package manager. This website is sort of the official documentation for NICs, and it's going to be more language focused. So if you want to learn about NICs as a language, this is a great place to go. But it also talks about here briefly, packaging existing software with NICs. That is one of its primary use cases, is packaging software. So let's talk about packaging software. In order to do that, we kind of have to talk about package managers. So if you're coming from the Linux world, package managers are probably you're so familiar with them, it's not even funny. You use them every single day, and it's just kind of a fundamental aspect of working on a Linux system. It's here on the Wikipedia, we've got apt-get, that's the Debian, however you pronounce it, or Ubuntu tool for packaging software. Gets used pretty often. A lot of distributions are Debian-based. But if you're coming from the Mac world, you may be more familiar with Homebrew. Mac is what's the term? Unix system. It comes with ZSH installed, and if you get a Mac at work and they say, hey, let's go get your machine provisioned, one of the first things they're probably going to say is, hey, get Homebrew installed, and then we'll use that to install everything else. So Mac, pretty familiar with package managers as well. If you're coming from the Windows world, you may not be quite so familiar. One of the big names in the space is Chocolatey. This is the package manager for Windows. And while it is a wonderful tool, it's not quite the same as the others because it's sort of a layer on top. Windows is not package-based by default. You've probably at some point in your career working on Windows installed via an MSI file, or maybe you saw one of those Install Shield installers, or you ran a wizard that helped you install software. Chocolatey kind of attempts to bring the Linux-isms into the Windows world. In case you didn't know, there is actually a first-party package manager from Windows called Winget. And it's not really a new thing. It's been around for a number of years now, but I feel like Microsoft hasn't really pushed it all that much. But in any case, it is first-party, and you can do package management on Windows. So I should have reordered these. We've got a couple package managers here. We've got, apt-get, we've got brew, we've got chocolatey, we've got winget. Linux actually has a ton of these. I just pulled up this, random Google search for, package managers on Linux. And, this is, I guess it's not too old. It's 2023, but, we've got apt, we've got yum, we've got DNF. There's also RPM kind of stuck in here, because RPM is sort of the format for Fedora, whatever. We also got Pac-Man, one of my favorites, because, package manager, Pac-Man, a little yellow guy with whatever. And there's even some that aren't even listed here. This is an Arch Linux package manager. We also have Yay and Yowert, which I'm probably mispronouncing, but there's tons of stuff. So, what does NICs add to the space when we've already got so many options already? One of the cool things that NICs brings is that it is functional, pure, and hermetic. This is one of the words that they've used in various places. I just thought it's a fun one. Maybe you don't hear super often. But it's kind of just saying that NICs is nice and sealed. There's nothing extra or fluff in there. So the gist of that, which I'll dive into a little bit more later, is that all of the package management is deterministic. So they have done a pretty darn good job at removing possible side effects, entropy from happening during the package management process. And there's a whole bunch of math that a lot of people smarter than me have come up with to sort of prove this. But at a high level, that's kind of what your takeaway is that NICs is functional and it is pure. And when you bring that to the Linux world, and specifically package management and operating systems, you get a lot of cool benefits. Okay, so let's dive into some actual code. Now, like I mentioned very briefly at the beginning, I'm going to attempt to focus on, again, the package management aspect of Nix. So there's a whole lot that goes into it. The Nix language, which we'll touch on briefly, just as it's applicable. There's Nix OS modules. There's like actually packaging things with Nix, and they all use Nix code, but they write them in like slightly different ways. And it's all convention, really. Apart from Nix OS modules, there's a little bit of type checking and validation there, but overall it's conventional. Nix is a very loose language and allows you to do just about anything with it. So we're going to talk about Nix Package Manager with just enough of the Nix language to make things make sense, hopefully, if I'm doing my job right. So I've got VS Code open here, and let's actually start out in the terminal. So when you install Nix, and actually let's go show that real quick. If you want to install Nix, head over to nixos.org, download, it'll take you over. You can install on a variety of different platforms. So Linux obviously being the main one, but they support Mac, Windows via WSL2, so actually Linux, and even Docker. So yeah, go ahead and get Nix installed. And then if we head on back over here, the install process will take a little bit, and it's wonderful. It'll walk you through almost step by step exactly what it's doing. But you will end up with the Nix CLI on your machine. So we can do like nix-help and get some nice output here. And there's a lot you can do. And I'm actually going to take the direction of explaining this using an experimental feature. Now, that may be a terrible idea. Why do a tutorial with an experimental feature? But I feel like in this case, it's kind of justified. The target audience here is somebody who is, loosely familiar with software development. You've worked in a project and, or at least kind of aware of some of the very high-level conventions that involve working with code on a day-to-day basis. So one of the most common things in just about any language you work in is there's some concept of like a project or like a grouping of all the files that are needed to produce the software that you are writing. So like in .NET, you have the CS proj or the FS proj. You also have the solution file, which is a way of grouping projects together. In Java, you've got Maven and all the POM files. There's also Gradle, which I'm less familiar with, but I'm pretty sure it's got a project system as well. In Node.js, you have package.json. I feel like most people have heard about that at that point. Python's got a similar thing. I feel like the ecosystem has been evolving, and I'm not a Python guy, so I don't keep up with it. But there's requirements.txt, which kind of defined, here's the scoping of like, here's my project, here's what it needs, and that kind of defines your output program. There's also, I know Poetry has come along. I don't know if that's actually like a project system. And there's UV, which all my coworkers talk about. But anyways, enough about Python. All of these languages have some sort of concept of a project. So for Nix, why I'm choosing to talk about one of the experimental features is that it sort of falls into that same slot. It is a way of defining sort of a Nix project. It's not the way you have to. It's all convention, of course, but I think it kind of helps for picking up some of the concepts. So I don't know how I've gone this long without saying the name, but the experimental feature I'm talking about is called Flakes, Nix Flakes. And there's a whole lot you can learn about Nix Flakes. We're going to keep it nice and simple and focused today and just talk about the package management aspect of them. So let's actually write some code. I said I was going to jump into code, and then I just started rambling again. So if we go in here, we can do nix flake init to create a new flake. And that failed, and I wanted it to fail because there's an extra step you're going to have to do after you install in order to get this working. So if we open up the nix config file on, I believe, both Mac and Linux, this is going to be under the home directory, the little tilde here. I point at my screen as if you can see that in the recording. But this little tilde over here kind of represents your home directory, and then the .config directory, and finally Nix. And within this, there will be a file called nix.conf. And if we open that up, it's just a plain text file. I think it's got kind of a sort of name assignment syntax. So kind of like the error message tells us here, we need to add extra experimental features. And we'll do an equal sign, and then we actually need two things here. So nix command is the first one, and I won't go on into what that is exactly, but just TLDR, we got to have it for flakes. And then, of course, the important part, flakes. So I forget if this is plural or singular. We'll find out in a second if it works or not. So now if I go back and do my Nix flake init, yeah, I messed it up. It is plural. All right, there we go. Okay, perfect. So that is the step needed to get flakes working on your machine. And there's a couple other ways you can configure this. This is just using the nix.conf like variant of configuration, but there's a couple ways you can do it. I think this one's probably the easiest. So I ran nix flake init, and what did that do? That created this little flake.nix file over here to the left. So if we take a look at this, there's going to be a whole lot of confusing stuff to get started with, but I'm going to delete this portion right here, and let's just talk about what we've got here now. So to kick things off, this flake.nix is sort of what I'm describing as the project system for like a Nix project. Again, I got to reiterate that it's convention. It's not specified by the community that is the way it is, but just for simplicity, we're going to talk about it as if it's a project file. So within this project file, you see the syntax isn't too crazy. We got some curly brackets. We've got like a name, which appears to be assigning a value, and we've got double quotes. So this is like string-ish looking. Oh, and we even have semicolons for those of you coming from languages with semicolons. And then that just kind of repeats. So we've got more names, assignment, and then more curly brackets. This kind of looks like an object if you're working in a language where curly brackets sort of delimit objects. And then we also have sort of a dot syntax here too. So we have like Nix packages dot URL, and that does have significance in Nix. And then finally, we got one last thing down here, which is a little weird looking, but we have, what looks like curly brackets and then a colon and some more curly brackets. So put a pin in that. We'll come back to that later. But sort of at a high level, like Nix is not all that complex. It's pretty generic. And it, honestly, at least in my opinion, feel free to tell me I'm wrong in the comments, but it kind of looks a little bit like JSON. I know, maybe a little stretch, but it's not too far off. And I'll tell you, from working with it, especially from the package manager point of view, it doesn't get too much more complex than JSON. There is some concepts here, sort of like the dot syntax, which kind of correlates to objects and property access. And spoiler, this is a function. This is how we can define functions in Nix. But we don't even need to do most of that to get started working with things. So package manager, how do we actually install packages with Nix? Well, in the little outputs here, so let's talk about a little bit about the structure, I guess. We have, description, a very basic flake. Yes, that is exactly the way it's going to stay. We also have some inputs and some outputs. So pretty simple. Inputs, you can probably glean by looking at the values here, but it looks like we're pulling something from GitHub, and it's going to be from the NixOS org in GitHub, specifically the Nix packages repo, and we can even specify a ref here. So we have question mark ref, I forgot what a question mark was, and then NixOS unstable. So this kind of throws together a whole bunch of things. So we have an input, and we're going to call it Nix packages, and we're going to set the URL for that input. And what we're setting it to is effectively a reference to a branch of a Git repository. So we take a step back. What's this going to do? This is going to make available to us the outputs that are specified in the NixOS Nix packages repository at this branch. And Nix expects some stuff to exist there. Obviously, Nix packages is going to be, it'll work as an input. That's what I'm trying to say. So now let's go talk about outputs. So we've defined an input, and outputs now lets us use it. So we have self here, which we're going to ignore. We're not going to be using that right now. But you can see our input we've got available to us here in the function arguments, which are sort of the left-hand side of this colon. So we have Nix packages, and that ties to this guy up here. So Nix packages is where the package manager actually starts to come into play. Nix packages is a collection, I think one of the largest collections of like Linux package software in existence. And it's all hosted on GitHub at the Nix packages GitHub repo. So we can consume those to kind of get a sort of little pseudo package manager here in our flake. So how do we actually go about doing that? Let's jump real quick into Nix shell. So yay, we're done with the flake.nix, and we're going to talk about the Nix shell. All right. So before we can really dive into flakes and how we can use them to install packages, let's briefly talk about the Nix shell. So Nix shell is a command line application. We can invoke it from the CLI. And, well, I don't have the man pages installed, so passing help was a bad idea. But TLDR, it's a command line application we can use. And what this does is this is sort of a pseudo package manager, as it were. So in other package managers like apt, I would install a package, maybe the bat package, and that would execute, and I would wind up with the software on my machine. Nix shell is similar, but rather than installing the package persistently on your machine, what it's going to do is it's going to install that package to the Nix store, and you can just ignore the Nix store. It's a magical file path on your system for now. But Nix shell is going to put that in your Nix store, and it's going to give you a shell that has access to that package on its path. So it'll work as if you had installed the package yourself. And let's demonstrate that. So we're going to pass an actual option that it supports. So we can invoke Nix shell and give the -p, and this is going to define what packages we want to be available. And we can pass this multiple times, but we're just going to pass it once. And let's install bat. If you're not familiar with bat, it's just like cat, but instead of a cat, it's a bat. Doesn't matter. Anyways, we can use it to print out things to the console in a nice, pretty way. Bat gives you like line numbers and a little bit of formatting on top of what cat would just print out what's there. So now we've got bat, and you can see my prompt changed a little bit too. So I'm now in a Nix shell prompt instead of my previous bash prompt, or ZSH, I think is what I have installed on here. But anyways, now, actually, I forgot a step. So if I go like, which bat? There's no bat here. If I try to execute it, command not found. But if I go back and do my Nix shell, and I say like, which bat? Would you look at that? We've got bat. And here's that Nix store. It's literally called Nix store with a whole bunch of gobbledygook that we do not care about. But the point is that bat is now on my shell and accessible to me. So if I do like echo hello world, and we just pipe that over into bat. Oh, look at that. We got some printing out. So, bat kind of gives us this little extra, whatever. But anyways, so that now makes software available to me. And that's all well and good. But I'm not going to, if I'm working on a development team and I want to have sort of a reproducible way to set up their environment, I'm not going to give them a Nix shell command. That's not something I can check into my repo. If I were to check it into my repo, it'd basically just be a shell script, which if we're going to check in shell scripts, why don't we just install the stuff normally with a shell script, So let's take this a step further. Now we have a reason for using flakes. Flakes help us define our environment and check it into a Git repository to share with our team, open source, whoever, doesn't matter. In this output section, there is sort of a little bit of structure that Nix understands. Again, it's all convention. Flakes have sort of a declared schema that they should adhere to, but realistically, you can put whatever you want in here, and it'll mostly work fine. The things that Nix does care about, one of them that we're interested in today, are called the dev shells. So we can do dev shells, and you could have multiple. So this is just an object. We're going to use sort of the similar syntax that we did up here for the inputs. We're going to do dev shells, and we're going to set the default dev shell. And now here's where we got to start getting a little bit more into some of the Nix specifics. So, and I forget what this is, so I'm probably going to mess it up. We'll fix it later. That's fine. But we need to specify the system that we're defining this dev shell for. Obviously, all these packages have to be compiled for a certain system, which is CPU architecture, and then the system strings, like Linux, Darwin for Mac, whatever. Same thing here. So we have x86. This is just what my system is. So mine's an x86-64 Linux system. And I think this is where I messed it up. Dev shells, default, x86-64 Linux. Anyway, we'll let that fail and figure out what the error is when it happens. But there's ways to simplify this. You don't have to specify the system every single time, but that's sort of out of scope for this video. So the next thing that we're going to do is we are going to make a shell, and a function exists called make shell, which does exactly what it says on the tin. It'll make a shell, and we'll pass it some arguments here. But we got to do a little bit more Nix in order to make this work. So oftentimes languages will have like built-in functions. Nix has some of those. Make shell is not one of them. So let's do a little bit of chicanery to make sure that we can call this make shell function. So Nix, being a functional language, has this concept of let bindings. So the syntax for that is pretty simple. You just do let in. That's sort of your start and your end, and then you can bind things to names within this little scope here. So we are going to try to keep things simple. What you'll see most often is you'll see a pkgs, packages, name, and this is going to be bound to the output of Nix packages, which again, I'm probably going to mess up because I never remember how this is supposed to look. But basically, we want to reference that Nix packages input, and then we want to go to legacy. I think it's outputs. Let's see, outputs, legacy packages, x86, 64, Linux. And yeah, well, I'm going to let that fail, and we'll figure out what the problem is, because there's something wrong here. But I'll let the tooling tell me what I messed up instead of just memorizing it, because who does that? Who memorizes things? I certainly don't, especially when it comes to making videos. But within packages, this defines a little bit more than just software, binaries. It also has some Nix functions in it as well. And as it happens, that's where the make shell function lives. So we can go ahead and do packages.makeshell. And this will instruct Nix to create a shell environment and assign it to this dev shell output. And now here's where the fun part comes in. Here's how we actually define the packages we want available. We literally can just have a name called packages, and we'll give it an array. And within this array, we can reference other packages. So let's do the same thing we did earlier for bat, and let's put that in this list. So in packages, we're going to have, this is basically just an object. In Nix, it's called an attribute set. Attribute set? English is hard. The top level attributes are package names, or mostly package names. Obviously, make shell is an exception. And that's really the gist of it. So let's run this and let's watch it fail and figure out which parts of this I messed up, because I most definitely did. So if we want to actually use this flake.nix, we can go back to the terminal, and under the nix command, there is a subcommand called develop. So if we do nix develop in this directory, it'll look for that flake.nix, and you can see it's already started downloading stuff. It's kind of flashing by, but it's downloading that tarball archive from GitHub for Nix packages. And it's going to make sure that's on my machine, so all the packages I asked for, it can make available to me. All right, there we go. Download finished. It was really slow this way. I don't know why. It didn't take that long last time I was doing this. But anyways, so we did get an error because I did in fact mess things up. And luckily the errors are pretty nice. They're not as nice as the Rust compiler errors, but I'd say they're pretty darn good. So it's going to actually tell us like what attributes it's looking for here. And it supports a lot of different ways of doing this. Again, it's very much convention based, but we really meant to do the dev shell's default. So it looks like I just kind of messed up the order here, and that's probably why I got confused earlier, is because it's dev shells, system, and then default. By the way, you can also do like Darwin. Of course, x86 Darwin is running out, but they're running out of support. But there's AArch64 Darwin, yada yada. So that's that. Now, I think I've also messed up the Nix packages stuff. So let's run this again, and hopefully it'll tell me what I messed up there too. So yes, what do we got here? Attribute output. Well, first of all, it's outputs. This is the same thing I'm referring to here, because Nix packages also has a flake with an outputs attribute. But I think I still messed it up. So let's have the CLI tell me exactly what. Oh, well, it worked. That was a surprise. I guess that was the only thing. Look at me guessing this stuff and things just working. But anyways, so what just happened? Well, first, let's revisit our Nix shell example. What I should find is I now have bat available to me. And again, we do, and it's at that Nix store path too. Let's just briefly look at the path here, because I think it will be different. We got like 2L2, and if we exit and do Nix shell-p bat, and then we do which bat, I guess there's also an at. But yeah, it's got a little bit different store path. And also, I think different version too, didn't it? Yeah, 1.26.1. So here's just a brief little note on how Nix does that like cool functional pure hermetic stuff. This is the like sort of Nix hash or representation of the Nix hash, which is like mathematically provable. It'd be like this is unique, and all the inputs that were used to create it will always result in the same output. So anyways, not the focus of this video, but I just can't help but mention it. So with this little dev shell, we can effectively define like a development environment. I could even do something like packages.python, because I just love to use tools that I don't work in on a day-to-day basis. But if I do nix develop again, it'll go through and probably have to download some stuff. But ultimately, I will end up with a shell that has both BAT and Python 3 available. And luckily, that was nice and fast because I did this earlier. But if I do, which Python 3, look at that. We got Python 3. It's in the Nix store. Awesome. The world is as it should be. So another thing that happened when we ran that nix develop is that you may have noticed that we have a flake.lock that appeared up here. So if we kind of open that up, we're going to go back here. If we look at the input, there's nothing here. Like we do have a ref, but there's nothing here that's really pinning this. People make commits to Git repositories all the time, and especially refs like this sort of generic looking like NixOS unstable, like this changes pretty frequently. So while it is a reference we can refer to, what that reference itself points to is going to be changing quite often. So that's not super great if we want like a reproducible environment. That sort of guarantee that like if it builds on my system, if it works on my system, it will work on your system as well. And that's what the flake.lock does. And this is one of the reasons why I like the comparison to like project systems in other languages, because if you work in like Node.js, for example, you may be very familiar with lock files. They serve almost the same purpose in Nix. They look a little bit different and they're using different values, but the kind of high level purpose of what purpose they serve is the same. So in here we have that nar hash, the Nix hash I was mentioning, that it keeps track of like the owner repo, and then it resolves that ref into an actual commit. And so this is the part that does not change. The ref will change, but the commit, how do we put this? The commit that the ref points to will change, but the commit will not change. This is pinned. It's going to be this commit forever. Barring GitHub doing something crazy and silly. And we even got some extra information here, which isn't super relevant. Lock file's got to have like a version. We're telling it like, hey, this is the root one, as opposed to being like a nested one, so on and so forth. But if we were to add inputs and we run, I think it's nix flake lock, they will show up in here. So this is how we get sort of that deterministic part. Somebody else cloning down this repo, when they go to run nix develop, Nix will look at this lock file, see that it exists, and see that, okay, this is the exact commit information that I need to pull in order to create that shell environment. And bada bing, bada boom. We have reproducible shell environments using Nix. There's so much more I want to talk about, but I gotta keep things scoped. So possibly, potentially, in a future video, we'll talk a little bit more about the Nix language. We'll probably package some software with Nix, maybe, possibly, and even talk about NixOS modules and the module system in Nix. There's so much cool stuff you can do with Nix, but here we've kind of scoped it down to just Nix as a package manager and how that enables you to have reproducible developer environments. This has been Eric with Technically Speaking at Source Allies. Do you have a topic you want to see covered? Comment down below and check out sourceallies.com to learn more about us. Thanks for watching, and we'll see you next time.